When we think about how microphones hear sound, most of us imagine air pressure hitting one side of a diaphragm. But ribbon microphones, like those restored at ENAC, work differently. They listen to differences in pressure, front versus back. This is called pressure gradient theory. Instead of measuring how hard the air pushes on one side, a pressure gradient microphone responds to the difference in air pressure between both sides of its diaphragm, or in this case, the ribbon. That difference is what moves the ribbon, generating an electrical signal proportional to particle velocity, the true motion of air. Remember, ribbon mics are also called velocity mics. See our video on pressure versus velocity microphones for a deeper explanation. When sound hits the front, it pushes the ribbon inward. When it hits the back, it pulls the ribbon outward. If a sound wave hits both sides equally, like from the side, they cancel out. This creates the classic figure 8 pattern: strong pickup at the front and back, and dead zones at the sides. The delay between sound arriving at the front and rear creates a phase difference, and that phase difference is what the microphone converts into a signal. That's how it detects direction. Ribbon microphones are highly directional, and that sensitivity to timing is what gives them their depth and realism. It's also why they exhibit the proximity effect, a rich bass boost when the source gets close. Some microphones, like the RCA77 or KU3A, add a twist, an acoustic labyrinth or shuttered port behind the ribbon. This labyrinth adds acoustic resistance and delay. See our video on acoustic labyrinths called Acoustic Labyrinth in Some Ribbon Microphones. By adjusting how much sound reaches the back of the ribbon, the mic's polar pattern can be shaped on demand. Partially closed shutter, you get cardioid. Wide open shutter, figure 8. Shutter fully closed, omnidirectional. The magic is in the air path. At ENAC, we preserve these legacy designs not just because they're iconic, but because they embody the brilliance of Harry Olson. Harry Olson was the pioneering RCA engineer who developed many of the ribbon microphone designs still revered today. He was responsible for the theory and invention behind directional mics, pressure gradient response, and the very microphones we now restore. His work shaped the sound of broadcast, film, and recording studios for generations, and the precision of real acoustical engineering. We owe Harry Olson big time. When you speak or sing into a ribbon microphone, you're not just recording sound, you're capturing movement. That movement may be a beautiful vocal for a song, emotional speech, or an entire orchestra. ENAC, thanks you for taking the time to watch. We hope it has been helpful.